professor, physician, epidemiologist. I am Dr. Sri Banerjee. Hello everyone, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy at Walden University. And in this video, I'm going to be quickly going over some of these really important topics that are fundamental to epidemiology, oftentimes missed, but if you present it in the correct way, it can really make sense and you'll never forget it. So let's aim for that. So for starters, what we're looking for here is we're looking at diagnostic test criteria. So for instance, I mean, the simplest example to look at is, for instance, diabetes, right? So a glucose level of, say, 125 is anything higher than that is considered diabetes. So if you consider 125 to be the cutoff, so let's say that we start off by cutoff number 1 being at 125 right here. So I'm just going to write that down just so that we don't forget. So 125. So that's the first cutoff. Then we decide to change that cutoff and actually increase it to, say, 175. So one question that you will oftentimes be asked on medical license exams in different places is the fact that how does that change positive predictive value and negative predictive value. So basically, if the cutoff increases like that from 125 over to, say, 175, then the negative predictive value would then automatically decrease. You can see this very distinctly. So negative predictive value would decrease, but positive predictive value, the ability to look at and find positives, will increase. So the opposite is true. If cutoff decreases, then the negative predictive value will increase and positive predictive value will decrease. So if you always draw this mental curve for the negative predictive value and positive predictive value separately, and then think of the cutoffs in the way that I just explained it in order, then you'll never forget this. The other thing that might help you remember this is understand that prevalence actually has an impact on at the same cutoff, and so you don't even have to change the cutoff at the same diagnostic cutoff criteria. If the disease prevalence were to increase, so for instance, now let's change the example that I just gave you and say you have 125 as a diagnostic criteria still. Anything above that is diabetes. But all of a sudden, instead of 10% of the population getting diabetes, 15% are getting it. So just based on that alone, your positive predictive value will increase and your negative predictive value will decrease. So you'll be able to, diagnose more based just on increase in prevalence. So the opposite is true as well. If disease prevalence decreases, then positive predictive value decreases as well, and negative predictive value increases. So the final thing that you want to think about is what happens when the overlap between positives and negatives are much closer. So it no longer is as easy to discriminate between positive and negative. What happens then? Well, then what happens is both positive and negative predictive value goes down. You're not able to any longer distinguish these cases in an effective and accurate manner as you were before. So those are the main points. When you change cutoffs, how does that change positive, negative predictive value? When you change prevalence, how does that change positive, negative predictive value? And then finally, when you change the overlap, how does that change positive, negative predictive value? If you have all of these points down, then you are all set for the USMLE. Of course, you'll have to make sure to know the equations. Make sure definitely to know those. But this is more of the conceptual portion of these concepts. Thank you for listening.